So I should just introduce myself. My name's Beth Medlick. I am the principal for clean energy and decarbonisation here at Digital Catapult. And I'm representing ADViCE, which is one of our core programs that we run in partnership with the Alan Turing Institute and Energy Systems Catapult. And we're going to be talking today about building sustainable AI. So let's get started. I think it's useful to kind of remind you of ADViCE's mission, which is to bring together an ecosystem of AI companies, industrial adopters, policymakers, and investors, all to support, promote, and coordinate the adoption and diffusion of AI decarbonisation applications. This is a big mission and it's an emerging area, but we hope to be kind of adaptive and flexible. And part of that is kind of reaching out and connecting with you as part of our community. So as I mentioned, this is a shared program. We have two other core partners who have been part of preparing the webinar today and who help us deliver the range of activities that we do with ADViCE. So we have Digital Catapult, who I represent, and we are a deep tech innovation organisation. So we really provide that deep tech expertise, and we help businesses to grow and apply deep tech into their organisations. Like the other catapults, we kind of sit in the middle between government, industry, and academia to try and accelerate progress in our particular areas. We've got the Alan Turing Institute. They are the UK's National Institute for Data Science and Artificial Intelligence, and they really provide that important link that we have with academia. And we have Energy Systems Catapult, so they are much more focused on accelerating the UK's transition to net zero. They also work similar to us by supporting innovators to helping them kind of design and commercialise that future energy system and what that looks like. We've been doing a lot of work over the past kind of year and a half to really understand what the challenges are in the AI for decarbonisation space. And there are a lot of them. There's a QR code here on the screen that you can scan if you want to explore some of the kind of challenges that we have been gathering across all of the core decarbonisation sectors. So they're divided into energy, transport, built environment, industry and agriculture, and we are looking to kind of build and expand on our understanding of the challenges. We can hope to kind of funnel the solutions into the right spaces. So you can kind of explore that as we go through. They are ranked according to their impact that they might have on the decarbonisation system. There's the AI suitability for that particular challenge. But yeah, it'd be great to hear if you are working on something that is maybe not represented in those challenge cards. We can explore that further as a centre of excellence. So this webinar series is part of some of our outreach that we do for ADViCE. So far, we've been lucky enough to host 7 different webinars on our kind of high impact challenge areas that we've identified as part of our research. And through doing that, we're able to platform innovators who are working on transformative use cases for AI in decarbonisation, give them a chance to speak about the work that they're doing. And you as an audience are part of a 600 plus strong attendee list to our live webinars. So thank you so much for joining today and hope to see you at some of our future events as well. So yeah, this kind of question of how we use AI to decarbonise industries without kind of adding to the problem elsewhere is a really big one. It's kind of a bit of a paradox, I guess, that exists in this kind of AI for decarbonisation space that we're really hoping to explore further, to lean into the kind of complexity and the uncertainty that this question poses. And within ADViCE, this is something that we're kind of embracing as a difficult question rather than presuming that we have the answer to this question. So part of the purpose, I guess, of this Sustainable AI webinar is to continue kind of building towards our understanding of the problem, and having those conversations, having cross-sector conversations, enabling people to ask questions, and explore further, and hopefully start kind of leading towards an answer that satisfies lots of different parts of our community. So I'm going to just start with a quick pulse check. It would be interesting to know, as attendees of this webinar, do you believe that the benefits of deploying AI for decarbonisation purposes will outweigh its environmental costs? We know there are environmental costs, but do we think that the benefits will outweigh those? There's going to be a pop-up on your screen. It should be there now. And it's just a simple yes/no question. And what we're going to do is ask you this question again at the end of the webinar and see whether, based on some of the talks that you've heard, whether your opinion or your answer to that question has changed. It'll be interesting to see whether that stays relatively static or whether your opinion's changed. So I'm going to see the results of that now. Okay. So we have a bit more of an optimistic crowd here today. 2/3 of you pretty much believe that the benefits will outweigh environmental costs. Okay, interesting. So we're going to be hearing today about how we can use AI for decarbonisation and lower energy impacts. So hopefully we're going to explore some of those benefits in a bit more detail, and we'll see how we end up at the end. So I've kind of touched on this kind of core paradox that we're covering today and the reason why we wanted to host this webinar. But I'm just going to go into a little bit more detail here to kind of explain the problem of sustainable AI. First is that we know that global electricity demand from data centers in particular is projected to increase significantly over time and even double by 2030, and this is a mad statistic that I was reminded of a couple of weeks ago, which is that this is equivalent to almost the entire electricity consumption of Japan today. So we know that AI is going to be a really significant kind of driver of increased electricity consumption, and that has emissions costs that go with it. So we know that this is an issue, and we know that not all electricity that we use at the moment is clean. We're far from that. But we also know that advancements in AI can really help us to solve some of those decarbonisation challenges as we carry on our path to net zero. So this is perhaps through optimisation of processes, of kind of combining new data sets, reducing really inefficient processes or replacing those. And there's been lots of research to kind of try and predict sort of the size of the saving that we might be able to find through using AI. And there's lots of kind of optimistic research, I suppose, on the benefits that this can bring, which will outweigh those kind of negatives of increased energy consumption. So that's the kind of the two different ends of the spectrum, I suppose, how we look at this question of sustainable AI. And I suppose for ADViCE, we don't have the whole answer to the problem, but part of the purpose of ADViCE is to really see what we can offer into this space. So one of the things that we do is to really advocate for funding and to prepare a kind of healthy innovation ecosystem space that's needed to drive greater adoption of AI for decarbonisation. So looking at where, building on those challenges, where are the challenges, where are the solutions that we can help kind of drive towards those solutions. The second thing that we do in ADViCE is to really try and build that body of kind of guidance, of awareness, of measurement frameworks that enable organisations who are working in this space to make more informed decisions about the emissions impact of deploying AI in their particular settings. So this looks very different and this can be very bespoke, but we want to help organisations and businesses to be able to kind of understand the breadth of the issues that they're dealing with, rather than perhaps assuming that AI is the only solution in a particular way. So we want to help them to do that. And then as a deep tech innovation organisation, on behalf of Digital Catapult, we really believe that deep tech innovation can provide some of those kind of systemic interventions, systemic leverage points to decarbonise the supply chain. And so we're looking to build on and explore those as well. So we've got 3 expert speakers today who are going to be talking on a range of different issues. And I'm going to stop talking so I can kind of hand it over to them. But I'll just introduce you to each of our speakers. So first we have Andrea Soltoggio, and he is an associate professor in AI at Loughborough University. And he's going to be speaking to us about how to reduce AI waste and improve efficiency. And this is really kind of building on those kind of core sustainability principles of reduce and reuse, and applying those to energy efficiency in AI. Then we're going to hear from Professor Alex Yakovlev, and he is joining us from Newcastle University. He's also a Literal Labs co-founder, and that's what he's going to be talking to us about today, his work with Literal Labs. And they use logic to improve efficiency and speed in AI models. There's obviously lots of kind of wider benefits that goes with that around cost and wider environmental impact. And then we're going to finish with David Stringer, who is a program specialist lead at ARIA, which is the Advanced Research and Invention Agency. They're a funding agency aimed at unlocking scientific and technological breakthroughs. And he's going to speak about efficient hardware, so providing us a slightly different perspective, but another really key part of the sustainable AI picture. So without much further ado, I'm going to ask Andrea to take it away. Thanks, Andrea.
Thank you so much, Beth, and good afternoon, everyone. It's a pleasure to be here today, and I am going to focus on my core research, which is about trying to make AI more efficient, as the title say. Next slide, please. Oh, I can do that. Can I also move to next slides or not? No, I'm going to ask you. Right. So we all know that AI is growing in popularity and everyone is talking about all these different potential use. And here is just a little snapshot of what is currently AI being mostly developed for. And so we have, starting from the left, manufacturing and industry. Control of robotics, processes is a huge field. AI in finance, of course, everyone is trying to understand how to use AI to understand financial systems better, to make better investments, to deal with our investments. And of course, there has been a lot of discussions around robotaxi, transport system, a very important area. What about medicine, personalized healthcare, healthcare infrastructure management? That's also an area where it is very important. For example, if we could save money for the NHS and make our health system better, of course, that would be an extremely crucial achievement. And there is so much more in terms of news, learning, information retrieval, entertainment, creative arts, and so on, right? So nowadays, essentially, we can apply AI to nearly everything. Next slide, please. But what do all these problem domains have in common? Clearly, language. So a lot of things we do in our world is based on communication. And so language is used for describing problems and describing solutions or designing solutions. There is, so the human in the loop is also what makes those tools relevant to us in the sense that we want to do something that is good for us, help us achieve our objectives. And finally, they capture somewhat our collective knowledge, right? And so all these principles are the same across all these different fields. But apart from this specific knowledge that takes a robot to move a piece, or the knowledge that determines whether I should make an investment or what medication I should take. These are very, very different. So does it make sense to develop huge models that they can do all these things at the same time? And the answer clearly is no. Next slide, please. And here we have an example of a clear example of how efficiency now becomes a very important factor when we use a tool. So here is just an example. You want a can of Coke and you just walk down to the nearest shop and you buy and you get it back home. Or you take a huge truck and you drive 200 miles to a shop and put the Coke back and drive back. Now, this seems absurd, but this is how AI works most of the time nowadays, because we have huge systems that they are developed to solve more and more complex tasks, to achieve better performance, and to do it faster and better all the time. And we are not really trying to optimize for what we really want to do. And so there are other aspects that make this problem particularly important. For example, I mentioned here in one point that AI is not lazy, in the sense that as humans, we tend to optimize. So even if we take a truck and drive 200 miles, then the next time we think, oh, well, you know what, I'm actually just going to walk down to the shop and buy it because it's less effort. But AI doesn't have that way to self-optimize. And so that means that sustainability doesn't just happen by itself, but we need to design that into the system. Next slide, please. So how do we go from the inefficient and unsustainable overuse and over-deployment of these massive systems to an optimized, minimal, and safe type of AI? I'd like to focus here on this graph on the right, and this is a visualization created by a colleague, Vincenzo Monaco, who is working on a similar idea. And he's had this brilliant idea of depicting AI modules like Lego blocks. They're quite small and they can be combined for the type of problem you need to solve. So the idea here is that we need to isolate knowledge and skills. And so we could first identify what is the minimum component that we could use. And then we could, for example, go out and search and fetch what we want. Then we can integrate into the specialized AI that we need for our task. But crucially, we can also remove bits that we don't need. And so we come up with a structure that just solves our problems just right. Next slide, please. And we are not just proposing this idea as a theoretical framework. We are also progressing from a scientific viewpoint, and in fact, in collaboration with a large group of scientists from around the world. Last year, we published this paper in Nature Machine Intelligence that describe a collective AI via lifelong learning and sharing at the edge. The title effectively says that what we are trying to do is to create systems that they self-optimize. They learn during a lifelong learning period, but crucially, they can communicate and talk to each other so that they can get the knowledge they want, so you don't have to retrain the system. They can optimize it. They can get rid of what they don't need. And so by doing that, they can really just solve the problem that they are trying to solve. And by doing so, there is a huge potential for optimization. Of course, there are other ways to optimize it, like, for example, reducing the energy for each part of the computation. There are many ways, but we believe that without this society of AI, we will not be able to progress any further. And if any in the audience is interested in this idea and would like to reach out and to talk more about it, I would be very happy. Thank you so much.
Thanks very much, Andrea. Really interesting talk to start us off. I'm going to save questions for the Q&A section at the end, and I'm going to pass over to Alex.
Hello, good afternoon, everybody. Thank you very much. Thank you to the ADViCE, and thank you very much to the audience for their attention and interest in our webinar. I would like to talk a little bit about the direction that I've been taking as a professor at Newcastle University and leader of the group on microsystems and co-founder of the Literal Labs, which is a startup company where we started about 2.5 years ago, and now we are going through the pre-seed stage. So the approach is essentially to look outside the box of deep neural networks or deep learning and seeing whether we can sort of in the core of the models that we use for AI, we could actually shift the paradigm towards energy efficiency and even explainability. And the trick here is basically use a logic-based approach. Can you change the slide, please, Beth? Right, so first of all, I'll talk a little bit about the problems and challenges and solutions. So as we heard, and we had it quite interesting sort of response to the question that Beth gave you about the whether we got more benefit or we've got so the disadvantages of AI. And in fact, I was quite inspired by your answers here. So we basically have good side of AI and bad side of AI. So certainly the AI promises more data and functionality at the edge would lead to increased productivity and profitability. However, we've got the actual situation here and reality. So we have several aspects here. First of all is that there is a hardware strain. So we've got more expensive hardware to look at. Then we've got the power blowout. So no longer fits edge power budgets. So the other thing is certainly no path to retrofit. And last but not least here is this requirement for the new network and cloud costs and reliance on the network availability. So all these factors, they have negative effect on the sustainability. So how are we going to sort this out? So Beth, next slide, please. So this is the Literal Labs proposition. So Literal Labs is proposing logic-based approaches to AI, which are essentially logic, truly Boolean logic we're talking about. The company was spun out in 2023, and it's based on 5 years collaborative research between Newcastle University and Center for AI Research in Norway. So there are 4 ingredients here for the answers to the problems that we just saw. The first of all is that we have to have significantly faster AI. So what we deliver here at the edge, 250x inference with logical AI models on today's silicon. And again, also addressing this hardware strain, so in retrofitting here. If we can afford designing new ASICs, application-specific integrated circuits, we can even have 3 orders of magnitude speed up. So the other aspect here is certainly ultra-low power. So because energy is time times power, so power is another ingredient here. So inference completed using logic rather than multiplication and heavy arithmetic allows us, even on the existing microcontroller platforms, to have 50x less energy benchmark. And again, if we can afford designing new integrated circuits, we can go down to the energy 4 orders of magnitude. So the other aspects are cost effectiveness. So inference runs on low cost existing silicon chips, so no special accelerations are basically necessary. And so low compute complexity enables edge training. And this is something that people don't normally talk about. How can we do training at the edge? So we don't need cloud at all. And finally, again, last not least, explainable AI. So logic-based approach and automata-based approach training and enable the explainability and interpretability. So next slide, please. So one of the kind of architectural elements beyond our approach, logic-based, is so-called settling machine. which is the machine, which is essentially it's a machine learning model, which is based on settling automata. And it was also based on propositional logic. So this type of machine learning model was proposed by Ole Christopher Granma, professor from University of Agder, that I mentioned that we collaborate with very actively. So the basic idea is combining this automata-based approach with propositional logic is shown here on this slide. So first of all, on the right of this slide, you see essentially the logic circuit, which contains certain literals like P, R, Q, which are Boolean literals, so they can values true and false, simply encoded with zeros and ones, and they form the inference process. Now, we train this inference process to give us the right decisions, essentially, by using automata, a large army of automata. And one of these automata is shown here. That basically, they give us two actions, essentially. One on the left, the other is on the right. And we have the states of this automata. They either present strong kind of conviction or strong confidence in certain action or weak confidence. As we move between these states, we move them through the issuing the reinforcement signals here, reward and penalty. We can train the entire kind of memory of our machinery here. What is interesting is that these automata, even going back to the early 60s when Mikhail Tsetlin proposed this kind of approach to machine intelligence, they had the property of expediency. So this is an interesting proposition here because you can see the expediency essentially as the combination of optimality and prudence. And that gives us a very strong angle to the direction of energy efficiency during training. And logic, as I said, that it is a possibility to put all the way down to the hardware, the ability to do very low power and low energy implementation of inference. Next slide, please. So we benchmarked to prove essentially the concept, how logic can improve the energy efficiency and speed on sort of the platforms that are quite commonplace. For example, so same hardware like ESP32 microcontroller, we can show and demonstrate here that we can, with a logic-based network, LBNs, versus neural networks, that we can work faster and we spend much less energy here. As you can see it, also, we can compare it against the quite popular models such as XGBoost, which is decision tree. So again, we can work much, much faster here. So next slide, please. And ultimately, if we have battery-powered IoT sensors at the edge, then we certainly allow the 10 years, up to 10 years using logic-based network. We can have battery life. And again, this is the legacy, so we don't propose anything significantly different in terms of the energy supply. And finally, I think we've got the last slide, Beth. Yeah, this is the way how Literal Labs is looking at the new type of product. So how are we going to deploy AI at the edge? So models and training tools enable users to use their data sets and create common, fast, low energy and explainable AI models. And so the Literal Labs training tools, they basically create a pipeline which produces en masse models that eventually these models can be either deployed on today's silicon, this is the at the edge application, or we could allow users to deploy it on effectively on the on-premises servers and perform decision intelligence. So if there are any interest in exploring further about both logic-based AI, Tsetlin machines, or the work of Literal Labs, you are very welcome to contact me, and at this end, I will pass to our next speaker, David. Thank you.
Thanks so much, Alex. Really fascinating to hear what Liberal Labs are doing, and I enjoyed kind of diving into the technical side more. So I'm hoping there's some technical brains who can ask some good questions in our Q&A section. For now, though, I'm going to pass over to our third speaker, David. Thanks, David.
Great, many thanks, Beth. Thanks for the kind of introduction earlier. I'm a program specialist at ARIA, and I'm going to talk to you about the work we're doing that's focusing specifically on AI hardware. For those unfamiliar, ARIA was set up by UK Parliament in 2023 with a really broad and ambitious remit, and that is unlocking science and technological breakthrough for the UK and the world. Put simply, we're a bold bets agency, and we fund scientists and engineers to pursue research at the edge of what is possible. If you could do the next slide, please, Beth. Beth spent a little bit of time on this earlier, so I won't spend too long on background, but I wanted to pull up this illustration. It's now outdated, but I think it really nicely captures the increasing size and complexity of frontier AI models. Here you can see the increasing size of GPT. It's unclear what the real number is for the size of GPT-4 and GPT-5, but estimates are that GPT has around 1.7 trillion parameters. And while the models are getting larger and more sophisticated, AI is moving into the mainstream, user base is growing. There's an estimated like over 100 million users in ChatGPT report that they get, like over 2 billion prompts a day. What this means is that there's a huge increase in demand for the compute required to develop, train, run inference on these models. And this computation all needs to be done on very sophisticated hardware at the moment, and it's incredibly resource intensive. So what does that compute actually look like? It looks like this. If you could go to the next slide, please. We're talking about huge pieces of infrastructure, essentially a warehouse filled with rows upon rows of racks and computers. This is a Microsoft data center in Wisconsin, and this houses hundreds of thousands of leading NVIDIA GPUs, and they require a huge amount of energy every day to run AI. In these AI data centers, rather than your typical data center that might be running many different small operations, such as hosting a website, these densities require the hardware to be coordinated to run like large jobs. It's estimated that a GPT-5 training run might cost $500 million, and thousands of megawatt hours to complete the run. And we're currently locked in this computing paradigm where these data centers are springing up all over the world, filled with GPUs, leading to massive energy and water demand. This takes me to the work that we're doing at ARIA. Given this growing demand for compute at a time when it's becoming harder and harder to squeeze more performance out of the compute that we have at the moment, ARIA has decided to focus on alternate computing paradigms. And we set out to ask the question, what if we could exploit principles found in nature to build dramatically more efficient computers? And the way I always think about this is, why does training a frontier model require a whole power station when the human brain can learn complex tasks on, 20 watts? Within this nature computes better space, in addition to other more isolated projects, we've got a 50 million coordinated research effort called Scaling Compute. Next slide, please. Scaling Compute aims to find out if we can drop the cost of AI hardware by 1,000 times, and in doing so, diversify the semiconductor supply chain, provide an entirely new vector for improved computing performance. In doing this, we'd unlock hardware that's more efficient, requires less water, has much smaller manufacturing costs and footprint. I'll now go on to talk about the program structure. We've broken this program down into a series of technical areas. Technical area 1 looks at components of existing compute platforms, these GPU data centers that we've spoken about. And this is split into the computation part and the interconnects part. The computation part looks at new types of chips that can be used to perform the operations that are are fundamental to AI in ways that are much more efficient than today, while the interconnects technical areas looking at ways to improve the connectivity. Can we reduce the cost of transferring information in and out of the chips, whilst there's a packaging section which is exploring how the chips are laid out and can we get, more in a smaller space. Technical area 2 is asking teams to completely reimagine the existing compute paradigm. While technical area 3, teams are building simulation tools that essentially will provide the map or the roadmap so the hardware teams know what they need to build. A funded mixture of universities, startups, larger corporations, and these teams are individually trying to tackle the different building blocks or components that are critical to this infrastructure that could collectively, if combined, lead to vastly reduced cost at the system level. That's cost, CapEx, OpEx, carbon cost, water cost. Through these projects, we're really trying to build a picture of, what could AI infrastructure look like beyond the NVIDIA GPU. I'm going to spotlight a handful of the projects that we're funding in this space. So technical area 1.1 focuses on matrix inversion. Inverting matrix is an operation that's less used in mainstream AI at the moment, largely due to the challenges with computing this operation in hardware. But there are many that believe like a large unlock in this space could be transformative for AI in the future. Normal Computing are an American software startup, and we funded them to set up operations in the UK to develop a new type of computing chip. They build physics-based computing chips to invert these matrices and explore applications in large scale AI models. The chips that they build, they harness the natural dynamics such as fluctuations, stochasticity, dissipation to compute far more efficiently than traditional chips can. While CPUs and GPUs consume a lot of energy, like enforcing deterministic logic, normal chips try and exploit stochasticity. Next slide, please. Matrix multiplication is far more critical in AI training today. It involves multiplying, vast, huge matrices. And today, information from these operations must be shuttled between the compute and the memory, leading to like a really significant energy penalty. We're funding one startup called Fractile. They're a UK company spun out of Oxford, and they're exploring analog and in-memory compute techniques to try and tackle this challenge. They believe the time is now right to be doing this as we're seeing lower and lower bit formats and leading models, and we're seeing, the NVIDIA GPUs, for example, supporting lower and lower precision as time goes on. Next slide, please. The interconnects area, this looks at technology for more efficient information transfer, as I said, and this is important over, a really large range of length scales. We're talking like down at the chip to chip level, all the way to, connecting up your data centers. We're funding Oxford University, who are exploring the gains to be had with completely new substrates. Can you squash your whole rack down to a single panel, putting more and more chips closer together on a single substrate? And they're aiming to introduce this new interconnect for, large scalable systems that will solve this communication bottleneck. Last of the projects that I want to talk about, I want to talk about simulation. There's a real need for simulation tools. How do people operating in this space know what they actually need to build? And the role of the project here is to actually guide the community and help them understand this problem. Big players in the industry, they have really good tools for simulating performance of their systems, but for new and non-conventional hardware, there's a big gap. If I'm developing a new type of compute chip, I need to understand how well that performs, not only at the chip level, but at the rack level, right up to, the whole system. I could build a component that's performing, 1,000 times better down at the individual chip, but, if that was never the bottleneck, that might only equate to, 100x when scaled up or 10x, 2x when built into a whole system. And so I really need to understand, what the energy costs, what the performance is going to be when scaled up. So we have two projects. We have IMEC, and they're the leading foundry R&D organization. They've actually set up an outpost in Cambridge in the UK. IMEC build these chips so they have access to data and information about these systems that no one else in the world does. And then there's a really strong team from Edinburgh, Imperial, and Cambridge building a similar tool. And these will be open source that everyone in the community will be able to interact with. I'll move on to my final slide and finish up there. You can head over to our website and read about read a bit more about any of these projects. I personally love talking about this stuff. If you want to continue the conversation, please reach out. My email's on the screen. You can also find me on LinkedIn, and I will be at Europe's this year if anyone would like to connect there. Thank you.
Thanks very much, David. Great to hear about the sort of range of solutions in the space. And also, I do think it's really helpful to have that reminder, your first slide with the size of the planets, just to kind of get into our head the scale of what we're talking about, because it can be hard to imagine, how much things are changing and how quickly. So I thought that was a really useful contextual slide. So thank you for that. Okay, so we've had all of our speakers, and you should have on your screen now the same question that you were asked at the beginning of the webinar, which is, do you believe that the benefits of deploying AI for decarbonisation will outweigh its environmental costs? I wonder whether anyone has changed their mind since we've heard from our speakers today. We've obviously been quite solutions focused today, so perhaps cause for more optimism, but I'll let you be the judge of that. And just a reminder, I think we had about 68% said they did believe that the benefits would outweigh the costs, so about 2/3 of you. Great, and once you've all had a chance to respond, okay, interesting. We've had a slight drop in the optimists in the room. Okay, that's interesting to know. I'd love to explore this a bit further in our Q&A so that we can understand why maybe you might have changed your mind, or what areas you might want to find out more about. I'm actually reminded of the Dunning-Kruger effect, which is that the more that you know, the less kind of sure you are about how big the problem is. So perhaps there's a bit of that effect going on here today. So there should be up on your screen an opportunity to add questions into a Q&A box, and we'll be choosing from those questions what to put to our panel. But I'd like to invite our panel now to put your cameras back on. I'm just going to start with an opening question to all of you whilst people have a chance to write in their own questions. Let me just push this forward. There we are. Thanks very much, everyone, for all of you for speaking to us today. I wanted to start because you focused obviously on your particular kind of areas of intervention or solutions that you are working on at the moment. But obviously we know that making AI sustainable really requires coordination across the whole system. So that's across academia, industry, and government. And I want you to reflect on what can we do kind of collectively, rather than finding solutions in our silos. What can we do collectively to try and accelerate that adoption of sustainable AI technologies and practices? Alex, let's go with you first.
Right. Well, I don't have obviously a super recipe here, but from the end of computer engineering, for example, and designing systems sort of from the bottom up, so to speak, I would say that the important thing is to see AI not just as a ChatGPT, large language models, which have the market of, let's say, billions of people these days, but see things around ourselves and see how these things that we have how they can actually enhance the overall productivity of the society. And this is where the uncharted kind of territories here, with lots and lots of benefits if we design things better. And in fact, it doesn't mean that we have to stuff everything with more and more sensors to do AI. That's the whole trick about AI. If we have too many sensors, we can use mathematical models and do all the predictions and all the controls and so on. But the whole trick about using machine intelligence is actually with as few sensors, few costs as possible, to actually perform things which improve productivity and efficiency. So my take on it is just take things outside the box, not this deep learning, but look at how AI can proliferate into the life where things could be, in terms of decarbonization. AI is for decarbonization rather than decarbonize the AI itself.
So it sounds like you're techno-optimistic.
Yes.
For how to get that cross-system acceleration. Okay, thanks, Alex. Andrea, any thoughts on what we can do kind of collectively to accelerate sustainable AI adoption?
Yes. So I think collectively, what we need to understand that is really important is the fact that right now AI is responsible for a massive economic growth. NVIDIA is the largest company in the world with a capitalization of $4.5 trillion. Something like unbelievable just a few years ago. And OpenAI, for example, 500 billion in capitalization. These companies, they live on the fact that they hope to create sustainable, cheap AI. Every time you query ChatGPT, if you have the free version, you're using the energy. So they are clearly investing a lot trying to produce efficient AI. And I wonder what difference we could make if I get like 1 million or 2 million funding for AI when an engineer at OpenAI can get 100 million signing bonuses. Maybe not everyone, but we heard the news, right? And so I think that what we need to understand that there are areas where these large companies are investing already a lot, and other areas where they are not. And where they are not is this sharing, is making AI a commodity that I can own. I can have my own AI, I'm owning it. At the moment, there is a centralization of resources. So few large companies, they are pushing the technology forward. And as a community, we are not very much part of it. Even if you have friends at OpenAI, they will not be able to tell you what they're doing. And so I think that's what makes it difficult for us. We need to really bring it back to the developers, to the smaller companies, to be able to construct AI at a collective level, not just at the large company level.
Yes, we need to kind of diversify the sort of ecosystem of innovators, in this space, so that it's not kind of too dominated by a few key players. I agree with you there. I think that's really what ADViCE is very invested in, is enabling that those kind of smaller deep tech companies to scale in this space and enable them to be competitive with those big players. Thanks for that, Andrea. Thoughts, David?
Yeah, I really strongly agree with the points Andrea was just making. We need far more diversification in this supply chain, in this ecosystem. But there's two other points I want to make. I think we need a much closer collaboration between those working on hardware and those building the models. Just Andrea spoke about how during his talk about how the models are not optimized for the task. They're also not really optimized for the hardware that they run on. We run our operations on the same hardware, so push towards more like specific hardware, I think will help. And I may be biased, but I'd like to see the UK make a real drive towards more efficient and sustainable hardware. I think we've got a real opportunity, given the talent pool here and the quality of the research coming out of the academic institutions, to get ahead in AI. I think it would be a big failing if we were putting all of our investment in building more of these big data centers, because we're not going to ever build as many as other countries that are investing a lot more in the space. staggering sums of money that I think we're never going to be able to invest here. So I would like us to think about, what comes next.
Okay, thanks all for that. Right, we have a few questions in the Q&A box, and just a reminder to participants that you can upvote questions that you particularly want answered. So do have a look at that, or add any of the questions that you would like to answer answered yourself. I want to pick up this question around the role of blockchain technology and the kind of what role does blockchain technology have in the longer term, and how does that kind of relate to some of the topics that we've spoken about today? Andrea, any thoughts?
Well, blockchain, I think it's been in the news because it tends to use energy and so get people worried about the kind of sustainability in the long term. But I would say that there is also a kind of security aspect to it. Blockchain is a way to ensure that whatever you own is unique. And so I think we need to separate the two aspects. And in a way, I think probably is this kind of Bitcoin mining sort of thing that went on the news and got people worried about it and the cost of the transactions in terms of energy. I don't think that blockchain itself will have any role in optimizing AI personally, but I don't know if the other panelists have different opinions.
Is it just adding to the problem?
It's an interesting piece of technology, but it's certainly not a solution.
I think there may be. I'm not an expert in blockchain, and I'm probably relatively uninformed about it. I think if it were to play a role, it would be in AI safety, and I think that safe AI is an important consideration when we're talking about the sustainability of AI.
Okay, I'm going to actually move on to a question here around the kind of global problem of AI's energy consumption. There's an interest from one of the participants about any of your collaboration, any collaboration that any of you have with other institutions in other countries. We've talked a little bit, we've touched on the kind of externalizing costs, I suppose, of data centers, where you can use AI for a particular decarbonisation challenge, but if all of the energy consumption is located in a data center in another country that has kind of different rules around disclosure of emissions impacts, that kind of thing, and that can sort of move the problem elsewhere. Can any of you speak on your international partnerships and how we can kind of engage with them better on this challenge? Andrea, I can see you've got your hand up. Do you want to jump in?
Yes. Well, I was very fortunate that I worked a lot with labs, particularly in North America and the US. I had some of my research funded by DARPA. And reading the question by Eugenia, I suppose. And yes, we do have active collaboration with universities such as MIT, UCLA, Johns Hopkins, Yale, really many labs. And I think that what I've seen that it's maybe becoming a little bit harder because of geopolitical tensions. We are lucky in the UK that we have good relationship with kind of establishing collaborative partnership with universities in the US. But I feel like maybe in the last 10 years, it has become more difficult. And this technology is regulated by export control and is considered also potentially dangerous. So right now, if you have a new AI algorithm, it is considered to be a highly sensitive type of information. And so that makes international collaboration sometimes a bit harder than used to be. And I hope that this is going to change because clearly it's only by global collaboration that we can address the big challenges.
Thanks, Andrea. I've seen a hand up from David. Do you want to?
Yeah, again, I just give the hardware angle on this. We fund a project at MIT at the Center for Bits and Atoms where they are looking at computers that can reconfigure it themselves to be applied more efficiently to the task that they are doing. This is, of course, like a very early stage academic research, but yeah, absolutely agree that MIT is absolutely at the front here, and we're working on some interesting projects with them.
Great, thanks. Alex.
Right. Yeah, just add on the international collaboration. So one thing it's in the domain of this logic-based approach and models, this settling machine approach that we followed, it started from international collaboration. And as you can see that the collaboration with the energy, not very frugal Norway. In fact, Norway is a producer of energy for many countries in Europe. So we work with them. So yet Norway is actually pushing for this quite economic approach to AI. And what is important is that the idea is that more democratized sort of AI in the sense of distribution and decentralization. And in that respect, settling machine approach is now, in fact, tomorrow I'm flying to Rome for the 4th symposium, international symposium on settling machines, which attracts people from all continents, essentially. And we see it's a prime example where we have the entire spectrum with settling machines. We cover from the very low level sort of devices. We even put settling machine into the flexible integrated circuits. Would you believe, through the pragmatic, for example. So we collaborate with them all the way to the level of quite significant sort of software solutions with text processing and things like that. So if you want to learn more, very welcome to see what's going on in this domain. Thank you.
Thanks so much. Yeah, I mean, no doubt we are all kind of working on the same problem from different angles across the different countries. So collaboration there is really important. I'm really interested to hear how this question is going to be addressed at COP30 this year. That's a really good opportunity, I guess, to be having those kind of cross-cutting conversations. So we'll see if that comes out as a key theme. I imagine it probably will, given all the attention on AI at the moment. We're coming near to the end, so I just wanted to leave us with a kind of bigger question. Any of the speakers can jump in on this one, but looking ahead kind of 10 to 15 years, what do you think a truly sustainable AI ecosystem would look like? David, come on in.
I would love to jump in because I think it's actually a point that Alex already made, but I think a sustainable AI ecosystem looks like far more equitable access to compute. Today, compute is so expensive. It's hard for researchers outside of the largest companies with the deepest pockets to like meaningful work on develop AI. So far more equitable access to compute and more distributed computing as well. I know Alex spoke about edge AI.
Thanks very much. Any final thoughts, Alex or Andrea, on the future? Come on in.
Well, I concur with David's comment. Really, decentralization. So we start with decarbonisation, but we have to decentralize and distribute AI, and that's the only way to get it to the level of sort of frugality, prodigality. So these are all combinations. And this expedience that I was talking about in terms of this use of approaches based on automata, for example, rather than on extremely energy hungry gradient descent algorithms, just as an argument, as an example. Maybe over to Andrea now.
Yeah, thank you. I think that there was nice complementary sort of viewpoints today, and now I'm glad to hear that this view that I suggested at first, that we need to have these blocks, these fundamental minimum blocks of AI skills and knowledge that they have to be transferable and shareable and decentralized. That would be one way to ensure that there is competition, there is optimization in terms of efficiency. And also another point I wanted to make is in relation to what David said about the hardware and software co-design. And I want to point out that this was the way it used to be for decades from the start of the kind of electronic revolution up to the 80s and 90s. And Intel, in fact, is one of the companies that most led this process, but Intel was left a little bit behind because now we have the separation of the design and the hardware. And so I think we need to remind ourselves that we were able to do that. And it's a matter of what kind of business model is more productive at the moment. And I think we need to go back to those schemes and way of operating that were successful a few decades ago.
Thank you so much. I feel like there's a million more conversations we could have. I definitely wrote down lots of notes that I wish that we could follow up on, but I think we're at time now. I just wanted to draw your attention to the link in the chat before this webinar closes. If you're working on a solution in the AI for decarbonisation space, we'd love to connect with you and hear what you're working on and support you in whatever way we can. So please do fill that out and get in touch with all of us. But for now, just thank you so much. Thank you especially to our speakers for sharing all of their knowledge today, and for our participants for joining in the conversation, and particularly to Jimmy, who is ill today, but he did a lot of the work to set this all up. So thanks all. Have a good afternoon. Speak soon.
Thank you very much.
Thank you.
Thank you.
Bye.
Speak soon. Bye-bye.
Bye.